All right. This is a good song. Hope you guys are having a wonderful day so far. My name is Michael. Welcome in. Welcome back to the stream. Today we're going to be taking a look at some more Python like usual. I got to stop saying that. I mean, nothing changes around here. So another day, another Python study session. So I really appreciate you guys for joining me here and hanging out with me. Let me know what you guys are working on and studying. Let me know how your classes are going, how's work. I appreciate you guys for being here. What's going on, everybody? Welcome in. All right. How is everyone doing? Bring this over here. All right. On that note, I'll go ahead and pause it for a second. Sweet, yeah, so welcome back in, everybody. It's another day, another stream with me and my pup. We're hanging out. Come here, Sky. Come over here. Come closer so I can give you a rub while I talk. I appreciate you guys for being here and hanging out with me. Like I said, thank you guys truly for being here. Today we're going to be, honestly, the agenda is kind of open-ended. I think what we're going to do is start looking at, we're going to watch Corey Schaefer's pandas videos. So we're going to need to use pandas, and see how we can use that and incorporate it into our projects and into the future. So no better time than now than to learn it, I guess. Let's go ahead and get warmed up with watching maybe the first two Corey Schaefer videos. If you guys aren't familiar with Corey Schaefer, he's a great teacher on YouTube. Unlike myself, I'm not a teacher, I'm just a doer. He's a great teacher. And so we're going to go ahead and take a stab at looking at some of his videos here. So let's look up his Pandas series. All right, part 1 here.
I took two things that I love, dancing.
Oh, yep, dancing and dogs. What the dog doing, Tim?
Types of an analysis or data analysis in this series. So in this video, we're going to be going over how to get pandas installed, how to download the data that I'll be using for most of this series, and also how to get all of this open in a Jupyter notebook so that we're ready to do some coding and analysis. Now, I'd also like to mention that we do have a sponsor for this series of videos, and that is Brilliant.org. So I really want to thank Brilliant for sponsoring this series, and it would be great if you all could check them out using the link in the description section below and support the sponsors. And I'll talk more about their services in just a bit. So with that said, let's go ahead and get started. So first of all, let's install pandas. So I'm using a clean virtual environment for this series, but you don't have to use a virtual environment if you don't want to. If you don't know what a virtual environment is and would like to learn more about those, then I'll be sure to leave a link to my video on that topic in the description section below if anyone is interested. So it's really easy to install pandas here. All we need to do is say pip install pandas, and we will let this run through. And once we have pandas installed, then let's also install Jupyter so that we can use Jupyter notebooks. Now, I was a bit hesitant to use Jupyter for this series because some people find it difficult to get the hang of, but honestly, if you're going to be doing a lot of work with pandas, then it's definitely a nice tool to use for this. So now, it's not necessary, so you should be able to follow along with this series just fine if you're using a regular editor, but Jupyter Notebooks allows us to actually see our data more easily by using the browser to print out our data in tables that make it easier to visualize. So I'm going to use it in the series, but you don't have to in order to follow along. So to install Jupyter, I'm going to say pip install, and this is going to be Jupyter Lab, and this is spelled Jupyterlab, Jupyter Lab. So we'll get that installed.
Nice,
Now, I'm not
funny.
going to go into a deep dive in
That
how to
sounds like
use
the life.
Jupyter in this series. I'm mainly going to focus on pandas, but if you'd like a detailed overview of how to use Jupyter, then I do have a video on how to use Jupyter in depth, and I'll leave a link to that video in the description section below if anyone would like to learn more about the details of using that. Okay,
We'll
so
have to
now we
check
have
that one
pandas
out
and
later
Jupyter
next.
notebooks installed. Now we're going to need to download the data that I'll be using for most of this series. Now, for anyone who's been watching my latest videos, you know that I like to use the Stack Overflow Developer Survey for different kinds of data analysis. Now, the reason that I like to use this data is because it's real-world data, and it has a lot of data in there that I think would be interesting to most people who are watching these types of videos. I've seen some other tutorials where the data just seems kind of unrealistic and not very relatable. So hopefully using this data will keep people interested and also give you a good idea of what it's like to actually download real data from a source and start analyzing it with pandas. So to download this data, I have this pulled up here
This
in
is
the
Pandas
browser.
Distracted
We can go
Funny.
over to the Stack Overflow survey results page.
We're
Now,
gonna
this
get
is
some
easy to
Pandas
find
knowledge
if you
here.
just Google it, but just to keep things easy, I'll have a link to this download page in the description section as well. Okay, now on this page, you can download the data in CSV form for any year that they have available. And now I'm going to go ahead and download the 2019 data, which is the top data here. And this should book and then this is usually helpful. We have a results public right here. First of all, if you download data that comes with a README, then this is usually helpful. We have the result. I brought open this up. So I'm going to go ahead and close these Finder windows open here. Go back to my terminal. And now within here, I'm going to navigate to my folder where I place that data. And this should be the same command on Mac, Linux, and Windows. So I'm going to say CD, and I'm going to go to my desktop. This is going to be wherever your project directory is, but mine is in this Pandas demo on my desktop. And once I am navigated to that directory, to start up a Jupyter Notebook, we just need to say Jupyter Notebook and run that, and we should see a server start up here, and it seems like it's taking a second. Okay, there we go. Now, back in our terminal here,
Blinded by the
Jupyter
lights.
server, and you will need to leave that terminal open while you're working in Jupyter. So Jupyter runs in the browser, so if you shut down this server, then you won't be able to access our notebook. Okay, so let's go back here to the browser, and this is where we have our Jupyter notebooks. So let me zoom in here so that we can.
Okay, so it's
so
just
that everybody
browser
can read this
based
fairly well. Okay, zoom
from
into about right there. I think
the
it's good.
terminal
Okay, so we
using
can see our
localhost.
data folder
Okay.
here that we downloaded and placed in our Jupyter demo folder a little bit ago. But now let's create a new notebook. So to create a new notebook, I'm going to click on New up here at the top right, and then I'm going to use Python 3. And now we can name our notebook. So up here where it says Untitled, I'm going to click here, and I'm just going to call this Pandas Demo and rename that. Okay, so now we're ready to start using Pandas. So we can import this by saying import pandas as PD. Now, importing pandas as PD is just a common convention when using pandas. So let's run that. And I ran that cell by pressing Shift and Enter. And again, I'm not going to go into the specifics of working here within Jupyter in this series, but if you'd like a rundown of the features and shortcuts that I'll be using, then I do have a link to my Jupyter video in the description section below. Okay, so for the rest of this video,
Slow down
we'll see how to load in our data and look at some information about that data. So our data is in a CSV format. So in order to read in that CSV, we can simply say df, which is going to stand for data frame. We'll learn all about data frames here in a bit. We're going to say df is equal to pd.read_CSV. We're going to use the read CSV method from Pandas here. And now we just want to pass in a path to our CSV file. Now mine was within that data folder, and that was within the file survey_results_public.csv. So now if I hit Shift Enter, then that will run that cell. So right off the bat, we can see that this is pretty simple to work with. So when using native Python, in order to read in a CSV file, we need to use the CSV module to create a CSV reader and things like that. But
Pandas
here,
has
we're
its
just doing
own.
this all in one line. So when it reads this in, it's going to read it in as a data frame. So data frames are pretty much the backbone of Pandas, and we'll go more into, we'll go over data frames and series objects in depth in the next video. But for the basics, a data frame is basically just rows and columns of data. We can see what a data frame looks like, but just by printing it out. And this is the great thing about using Jupyter Notebooks, because it allows us to visualize these things in ways that we can't do in other editors. So here in Jupyter, I can simply just say df and run that, and it will print out our data frame here. So we didn't even need to wrap this here in a print
Hmm.
function. Now, if you're
Okay.
using a normal editor, then you can still print out data frame information, but it's not going to look as good as it does here in Jupyter, where we get this interactive table. So this is a small look at our data. Now, this is actually 85 columns here, but if I scroll through these, then it doesn't look like there's actually 85 columns printed out here. So this is actually concatenated by default just to give us a broad overview of the data. So by default, Jupyter is displaying 20 columns from our data frame. Now, how did I know that there was 85 columns for this data frame? Well, there are a few attributes and methods that we can use to get an idea of what our data looks like. So
Okay.
first, we have the shape attribute, and shape gives us the number of rows and columns in a tuple form. So let's look at this. So in our next cell down here, I'm going to say df.shape, and I will run that. Now, this is an attribute here. It's not a method, so you don't want to put parentheses. So df.shape, and we can see that we have 88,000 rows and 85 columns. Now, if you wanted a bit more information, then we can use the info method. The info method will give us the number of rows and columns and also all of the data types of all the columns as well. Now,
Hmm.
before I run that, it looks like my text is getting cut off here a little bit. Sometimes this happens whenever I'm within Jupyter. In order to fix this, I usually just come up here and restart and run all my cells again. That usually takes care of the problem. Let's see if that works. Okay, so that seemed to work. Another thing that you can do here is just to totally reload the page in the browser. And when you reload the page, I think it's just because of how I have this text enlarged, so it's kind of messing with how these look, but now we can see these just fine. Okay, so like I was
I don't
saying,
see any
we can
difference,
see
but
here
okay.
that we have 88,883 rows and 85 columns. Now, if you wanted more information, then we can use the info method. And that will give us the number of rows and the number of columns, but also all of the data types of the columns. So
Okay.
let's run
Info
that. So if
method
I
and
do
shape method will give you.
df.info, whoops, df.info. Now, this actually is a method, so we do want to put the parentheses there. And let me run this. And now let's go over this output. So we can see here that it says that we have 88,883 entries, so those are our rows. We have a total of 85 columns, and then it lists all of our columns here for our data. So these are all the columns in our CSV file that we have loaded in. Now, it also gives us
Okay.
the data types of each of these columns. And we're going to go over data types in a future video. But for the most part, objects usually mean strings. And then we have other things as well. So int64 is just an integer. Float is a float, so
Okay.
probably a decimal number. And there are no other data types in this data set. But there are more data types in general, so I will be sure to do a video on data types specifically in the near future. Okay, so now that we know the number of rows and columns, let's change a setting here within Jupyter so that we can see all of the columns. So I think it would be useful to see all of these if we'd like to, even if there are a lot of these to scroll through. So to do this, we can change a setting, and I'm going to come down here to the bottom here, and I'm going to change a setting by saying pd.set_option. And within here, I will say display.max_columns, and I will set that equal to 85 so that we can see all of our columns. And I will run that.
Display
And
max
now,
columns
if we print
85.
out our
Okay.
data frame,
Now
so
it'll
I'm going
give
to
you
go
all
back up
85
here
columns on the
to where we
print
printed
of
out
just DF.
this data frame, and I will rerun that cell. And now if I scroll through these columns, then we can see that now it looks like we actually have these 85 different columns here. So I can keep scrolling and keep scrolling, and it didn't just chop us off at that 20 like it was before. Now,
Okay.
obviously, the rows are also being concatenated here, and we definitely don't want to print out all 89,000 of these rows, but there probably are some examples with certain data sets where you might want to see all of the rows as well. So for example, I said that the survey results schema.csv file that was included in our download gives the matching questions for all of these column names here. So if we wanted to see what these column names here mean for this data, then we can load in that schema CSV file as well. So let me do this. I'll go down to the bottom of our notebook, and I will just load this in by saying schema_df. Now, I don't want to
Schema.
just call this df because we don't want to overwrite our other data frame. And I will load this in just like we saw before by saying pd.read_csv. And this is within the data folder, and this was called survey_results_schema.csv. So I will run this, and now let's look at this schema data frame that we just loaded in. So here, we on this column here, this gives us all of the columns in our other data frame. So we have respondent, main branch, hobbyist, and if I scroll up to that data frame here, I'm going to delete this info here since we no longer need that. If I scroll up to this data frame here, then we can see respondent, main branch, hobbyist. So if we want to know what these mean, then that's what we use the schema for. So we can see that main branch or hobbyist means do you code as a hobby? Main branch means which of the following options best describes. Now it actually concatenates the text too. In order to actually see this the full text, we could either change an option or we could just access this value directly. And I will be showing you how to do that in the next video. But for now, we can see that we can't see all of the rows to the questions that correlate to each column name here. Remember, we have 85 columns, but for here we can only see the first 5, and then we get this ellipses here, and then we can see the last 5. So let's set this up so that we can view 85 rows and then reprint this so that we can see all of these. So back in the same cell where we set our max columns, now let's also add one for rows as well. So I'm just going to copy and paste that, but instead of max columns here, I'm going to have this be max rows, and I will run that. And now we will rerun this schema here, and now we can see that we can see all of the columns and the corresponding question text. So if you wanted to know what any of these columns mean, then this is how we do it. So we can see IT person. The question was, are you the IT support person for your family? So that's probably a yes or no question. So that is what those mean. So if you're going through this data on your own, then you can use this as a reference anytime you don't know what a certain column means in our survey data. And if you don't know, or if you don't want to look through all of these to find a specific row for a specific column name, then in a future video, we're going to learn about filtering data frames and see how we can just grab a specific row where the column equals a certain value. Okay, so now we have all 85 rows visible of our schema data frame here. But you might be thinking, well, that's nice, but I don't want to see 85 rows of my survey data every time I want to look at it. But there are a couple of methods that we can use to only see a certain number of rows, which you'll most likely use a lot just to get an idea that your filters and data frames seem to be working correctly. So we can see the first 5 rows by saying, instead of doing a df here, we can say df.head. And if I run that, then we just get the first 5 rows here, okay? And you can pass in a value if you want to see a certain number of values. So if you wanted to see the first 10 rows, then we could pass in a 10 to df.head, and this gives us the first 10 rows. So we can see it goes all the way down 0 through 9 there. Now, if you'd like to see the last rows instead of the first rows, then we can use the tail method instead. So if we say df.tail, and we could use it without a number also, but if we pass in a number just like with head, then now we're going to say that we want the last 10 entries here in our data. So those are the last 10 items of our data. Okay, so this is a brief overview of getting pandas installed and then downloading our data and loading our data into Jupyter and how to read this in. Now, before we end here, I'd like to mention the sponsor of this video, and that is brilliant.org. So,
all right, cool.
Also learn about the series data type. So we'll learn how we can think about data frames.
Nice. All right, that wasn't too bad. So let's go ahead and should we create a Jupyter notebook then for this my notes of this? So let's go ahead and I'll create a directory here in my repos, in my general notes directory, Corey Schaefer YouTube, new folder. This is Python pandas tutorial. Okay, and then let's code at this terminal, this here. So let's put this over here. Let's put this here, and let's see what that is like here.
In a way that's easier to understand, and also see how we can grab certain elements called.
Okay, so
hey there, how's it going? We're going to be going over sponsor for the series, pandas, and we will let this brilliant just for Python. And
he's in a virtual environment. Okay, so we're in Python Pandas tutorial. Let's go. Okay, who knows how to install a virtual environment off the top of their head or setup? What is it? Is it VENV? No. Anybody remember off the top of their head? I'm not trying to look it up. Can we remember? Can we remember it? Anybody? Hey AG, how's it going? Hey Carlos, yes, we're back to code, my friend. Welcome in. How you guys doing? Welcome back. Anybody remember the virtual environment? So it's VENV. Well, VENV. Uh, Come on, guys. Don't leave me hanging here. I'll give it a second here for the delay. If anyone's got it. Anyone got it? All right, we'll go to the Almighty Orb. Can you remind me the VNV command to start a source VNV bin activate? No, to make Python dash M VENV VNV. Ah, that's close. Python dash M. Oh, Python 3. Okay, let's go pip. I want to update pip and this virtual. So let's go pip install. So let's see what he says. He says,
For since it's using some interested in have pandas, and we will let this run through. And once we have pandas installed, then let's also install Jupyter so that we can use Jupyter notebooks. Now, I was a bit hesitant to use Jupyter for this series because some people find it difficult to get the hang of, but honestly, if you're going to be doing a lot of work with pandas, then it's definitely a nice tool to use for this. So now, it's not necessary, so you should be able to follow along with this series just fine if you're using a regular editor, but Jupyter Notebooks
"Oh, I
allows us
didn't activate my. Oh shoot! I installed pandas to my global environment. Pip. We go bin or source bin slash VENV slash dot. This might be source VENV slash bin slash activate. There we go. Pip install pandas. There we go. Go pip install. Okay, cool. So we got pip upgraded. We got pandas installed here.
to actually see our data more easily by using the brace J install, and this is going to be Jupyter Lab, and this is spelled Jupyterlab, Jupyter Lab. So we'll get that installed. Now, I'm not going to go into a deep dive in how to use Jupyter in this series. I'm mainly going to focus on pandas, but
There
if
it
you'd like a
goes.
detailed overview of how to use Jupyter, then I do have a video on how to use Jupyter in depth, and I'll leave a link to that video in the description section below if anyone would like to learn more about the details of using that.
Nice.
Okay, so now we have pandas and Jupyter Notebooks installed. Now we're going to need to download the data that I'll be using for most of this series. Now, for anyone who's been watching my latest videos, you know that I like to use the Stack Overflow developer survey for different.
Okay, so he gets the data, whatever. I don't need to know about that. So starting a Jupyter notebook.
Terminal. So then here, I'm going to navigate to my folder, but mine is in this pandas demo on my desktop. And once I am navigated to that directory, and we should see
To go Jupyter notebook. Uh-oh. Um, JUP.
a server startup here, and it seems like it's taking.
Oh, we didn't get it. Not us. Let's see here. I did pip install Jupyter Lab already. So we'll go Jupyter Lab. Oh, hey, oh, look at us. Okay, here we go. Nice.
In a second. Okay, there we go. Now, back in our terminal here, this will run a Jupyter server. And so if you shut down this back there, I think is good. Okay, so we can see our data folder here that we downloaded and placed in our Jupyter demo folder a little bit ago. But now let's create a new notebook. So to create a new notebook, I'm going to click on New up here at the top right.
New launcher. Okay. Okay, we got that. So we got our note. Okay, so then I can go.
And then I'm going to use Python 3. And now we can name our notebook. So up here where it says untitled, I'm going to click here and common convention when using pandas.
Oh, let
So
me
let's run
skip.
that.
Come on.
And I ran that cell by
Import pandas as PD. Import pandas module. Lib. PD. Okay. We import the pandas library. Lib. Whatever. As PD variable.
my Jupyter data, and we'll learn about here. And now we just want to pass in a path to our CSV.
Okay, so it goes df equals pd.read CSV with quotes inside here, and then some sort of path in here. Okay. So, oh, not what I meant to do. I meant to just go enter. Now it's can we zoom in here? Yes, we can. Okay. Hey, how's it going, AZ? How's it going, Abhishek? Abhishek. 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 I think that's how you pronounce it. Abhishek. Hopefully I pronounced that right. Okay. D-frame is a data frame. Um, so can you give me a general def for a data frame or a DF in pandas? A data frame in pandas is a two-dimensional labeled structure. A 2D labeled data structure that similar to a table in a database and Excel. Can I wrap text? How to wrap text in Jupyter. Um, Press the M for markdown mode. Okay, gotcha. Huh. So it detects the code, recognizes a comment here. Oh, this is code, this is markdown. So this is, huh. Abby will do. All right, nice. Great to have you in here again. How's it going, man? No code. So we'll do this one as markdown. So let's say a data frame in pen is a two-dimensional labeled structure similar where each column, like so. Here. This is a point here. Okay, so a data frame, a two-dimensional labeled structure that's similar to a table in a database, an Excel spreadsheet, or a SQL table. It consists of rows and columns where each row can hold a data of a different type, integers, strings, floats. Um, each row is indexed with a label, often integers by default. It's often on top of NumPy and is optimized for performance and flexibility with large data sets. Gotcha. So then you go, we'll do this df equals to pd dot read CSV, given some path here. What we'll do is we'll comment here, we'll say pd dot read CSV um, returns a data frame the content within the right.
CSV file. Now mine was within that data folder, and that was within the file survey underscore results underscore public dot CSV. So now if I hit Shift Enter, then that will run that cell. So right off the bat, we can see that this is pretty simple to work with. So when using, great thing about using Jupyter attribute, and default, Jupyter is displaying 20 columns, a bit more .info.
Okay, so we have df.shape. Let's go get this data set that he's using. Stack Overflow Annual Developer Survey. Um,
Data here. So I'm going to download this.
there we go.
CSV here, and then we'll click on download again, and this should go ahead and download this for us. Okay, it did. And now I'm going to open this.
Okay, so let's take this. We'll throw it into our thing here. Okay, so now we'll go out of here, back to here, reload our site. I don't see our folder. Huh. Where'd my folder at? It's in my VS Code here. Oh, I closed it. No, I don't have it here. Okay, so hold on, let me take that survey and put it in here. It's not there. Close this. Back to here. Jupyter Lab. What's going on? Oh, I'm. What is going on? Am I tripping?
To install Jupyter, I'm going to say pip install, and this is going to be Jupyter Lab, and this is spelled Jupyterla.
Where's my data set? Is it not going to
Jupyter
show it?
Lab. So we'll get that installed. Now, I'm not going to go by everything that I'm saying here. This will make a lot more sense once we open this up in Jupyter. So let's go ahead and do that. So to open this in a Jupyter notebook, I'm going to go back to my terminal. So I'm going to go ahead and close these Finder windows open here, go back to my terminal, and now within here, I'm going to navigate to my folder where I place that data. And this should be the same command on Mac Linux project to that directory. Run that, and we should see a server back in our terminal here. This will run a Jupyter server, and you will need to leave that.
I added files to my dir, but Jupyter isn't showing them. CD to my folder in Jupyter Lab again. That's what I did. Jupyter Lab. It's not there. Anybody know why I can't see my recently added in data here? Why is it all funky? Oh, I'm in Untitled. Let's go here. Now we're in Python Pandas here. Now if I copy into Python Pandas, this and this, make a new folder called data, not dot dot. Put these two files in there. Now if I go Jupyter Lab, oh shoot, I've got to go gotta go source venv/bin/activate, and then go Jupyter Lab. There we go. Okay, data. Okay, there we go. Now we have it. So now we'll go data slash copy path. And put that there. So now if we run this, PD not defined. Oh, I want this to be number 1. What's going on? Like, where's my stack at? My call stack. How do I change the order here of these? Oh, nuts. How my top cell has a 5 next to it, not a 1. Kernel on the top menu. This 1. This is 2. Then copy df, and that's 3. There's df. So let me go here and go comment. No, we don't need to do any comment. It's fine. Okay.
Terminal open while you're working in
Then he does some of these other things.
phone using a how did I that we
df.shape. So this is so we'll give this a markdown then. No, df.shape.
have 8 data frame 825 column number of rows and columns in a tuple form. So let's look at this. So in our next cell down here, I'm going to say df.shape, and I will run that. Now this is an attribute here. It's not a method, so you don't want to put parentheses. So df.shape, and we can see that we have 88,000 rows and 85 columns. Now, if you wanted a bit more information, then we can use the info method. The info method will give us the number of rows and columns, and also all of the data types of all the columns as well. Now, before I run that, it looks like my text is getting cut off here a little bit. Sometimes this happens whenever I'm within Jupyter. In order to fix this, I usually just come up here and restart and run all my cells again. That usually takes care of the problem. Let's see if that works. And run all my cells again. In order to fix this, I usually just come up here and restart and run all my cells again. That usually takes care of the problem. Let's see if that works. Okay, so that seemed to work.
Okay. So then this is df.info. Turns all that. So df.info returns all that. This is a method though.
total of 85 columns. We'll set that equal to 85.
Oh, it says pd.info? Oh, df.info. pd.set option. So then we have this. So pd.set option, quote, display dot max columns will be 85. Set the pandas display columns option to show 85. No such keys. Display max columns. PD set option display dot max underscore columns. So now if we go run this, we call df here. So in here before we got a bunch of columns. Now here we got 84, but here we got job stat, job stat. So if I go here, set option to 114, run. Still getting job stat.
Out our data frame. So I'm going to go back up here to where we printed out this data frame, and I will rerun that cell. And now if I scroll through these columns, then we can see that now it looks like we actually have these 85 different columns here. So I can keep scrolling, and it didn't just chop us off at that 20 like it was before. Now, obviously, the rows are also being concatenated here, and we definitely don't want to print out all 89,000 of these rows, but there probably are some examples with certain data sets where you might want to see all of the rows as well. So for example, I said that the survey results schema.csv file that was included in our download gives the matching questions for all of these column names here. So
this one. Oh, yeah, way more columns. It's just, this is giving me a summarized. Or would it look at it? I have a dot here. No, there. Okay. Hey, how's it going? Hey, Mr. Old Player, thanks for chatting with me on Twitch. What's going on? Hey, Darko, what's going on, dude? Well, welcome back. What phone do I have? iPhone 14 Pro Max. I've been wanting to get an upgrade though, but you know, nothing's really been too much different. Hey, Askel. Hey, how's it going, Eduardo? All right, so we got the info. Loading schema data. Max columns. Then he does. All right, and then he does schema df equals to pd.read csv. He puts in here the data path. That. Now he goes schema underscore df, right? It just prints it. There's the schema. PD set option max rows 85 too. 114 rows. Run that. And then run this. Now we get 86, 87 rows. Let's see here. Alright, so 86. The schema. Head 10. Tail. So then it goes df dot head with the int here. Give the first int rows. Df dot tail int last int. Okay. Alright, that's enough of that for today. It's a good intro to Jupyter here and how to get into it here. And then, so you can just basically execute code line by line, which would be kind of useful for like leak code stuff, honestly. Because then you could see everything. It's like a debugger, but even better, but live. What do you guys think? Do you guys use it for like leak code solving and stuff like that? Okay. Count complete tree nodes. Okay, given the root of a complete binary tree, return the number of nodes in the tree. In less than O of n time complexity. Okay, so we have to, given the root of a complete binary tree, return the number of nodes in the tree. According to Wikipedia, every level except possibly the last is completely filled in a completely binary tree, and all nodes in the last level are as far left as possible if it can have between 1 and 2 to the power of height nodes, inclusive of the last level of h. 6 nodes total. So we have to go have recursive algorithms O of n, less than O of n. So we have to use a log algorithm here. Well, what log algorithm? Well, we have binary search. We're not searching for anything. We're just trying to get the value so we can split the tree in half. Right? Recursively call. So the thing is, we have to do this in less than O of n time, logarithmic time, right? So what tree algorithm runs in O of log n time? I'm getting tired. I'm tired, you guys. These late hours are catching up to me, little by little. I'm getting wrecked. All right, so if we go, which one was my trees? Arrays, stacks, cubes, linked lists, trees. So the post order, that's O of n, O of n, O of n, O of n. All of my algorithms are O of n. um, these are my notes that I took. These are my personal notes on my readings of data structures and algorithms in Python up to chapter 11 currently so far. You can get these on my Discord and on my which is linked down below for free, and also on GitHub. But yeah, I am pretty dead. I am tired, man. So we have to write an algorithm that runs an O of less than O of n. So if we I mean, my first idea is like, I don't think it'll work though. Like, you'll start on the node, you'll have a count for one right there, and then you say if the node you're on has, like, if the node you're on has a left, count increase right, count increase. If the node has a right, count increase, and then call helper on left and right, and basically travel downwards. But then you're calling the helper function on every single node, which is O of n. Right? Two-hour lead code versus 10 hours sleep. Definitely wish I need some. I need to. I need to go to bed before midnight tonight. Preferably before 11. Right, so I mean, that's my first instinct is to, right, so if root dot left count plus equal 1. Okay. So let's think here. So count plus equals, and we call helper root dot left. If root dot right count is equal 1 helper. What do we return? So if root left count plus equal 1 root left. If the root right count plus 1 help root right. We return those values back. So we want to return count. This to count gets returned back here. Okay, gets returned back here. Return count at the very end. So say if root so if not 0 return 0. Else while root dot left root. So while root while there is a root dot left, count goes up, or left length goes up by 1. We move root equals to root dot left. But the thing is I need to, now my root is, now my root is down at the bottom. So I need to save a copy of it. Copy equals to root, while copy dot left, length left, copy dot left, so just copy. Right, and that'll keep going. We need to do the same thing then for copy left, copy right. This way, right length, copy dot right, right length, right. If return to the power of copy or of left length if left length equal to right length, else helper root count. I don't know, we'll see. So I have this helper function which will do the counting. If it has a left child and right child, to count it, right, and then move to that one, and recursively return the count back to us. So then if not root, we return 0 right away. We take a copy of the root. We go down and traverse the left length. We take a copy of the root and traverse the right length, or the right height. If those are equal to each other, we return them, else we return helper root count. Copy left, copy right. Right. Copy left. Hmm. Dang it. All right. Tim really wants us to play Minecraft again. He's been asking for it. I've been feeling bad. So I return 2 times the power of the... Every level... Huh. I know, this feels like a lot. Hey, how's it going, Creative Corner? Welcome in. I appreciate you joining me again. Or joining me. Hey, Manal. How's it going? Okay, so anybody have some input here on where we could go from here? So we're failing both cases. Return 2 to the power of the left length if left length is equal to right length. Else, we call helper root count and return the value that was given back to us. So this is returning a number. We increase the count on the root call and we call deeper. So I think it might be this. So then where should we put the return statement? We don't want to return the function back. If left root, if not. So if it doesn't have a left, it doesn't have a right. So we need to, so if not root, so at the end we'll just return back and then we'll return count. So we get it at the very end. Still getting the same outputs. So if not root, we return. Let's just return 0 then, and let's, instead of passing in a count, let's just do a root, return 0. So that'll return, we call count equals to 0. Right, and then say if root left, we aren't going to increase count, we're going to return count plus equal this. So initially count is 0. So 0 will be returned. Yeah, it's my same name on LinkedIn. Hey Manal, how's it going? So if not root, we return 0 in the helper. Else we say count equals to 0. And then if the root left, we return the helper. So basically, so do we increase count by 1 here and return it at the very end? If not, then we go into, so let me return. Valid syntax. Return count plus. count will be 1 for the initial root. Right, if there's a root left, you increase it. We're going to count plus helper. Still the same outputs. Dang it. What do you guys think? Okay, so hold on, let's do this. Instead of doing this part here, let's say while so we'll say height is equal to 0, is equal to 1, and we'll say while root dot left and root dot right copy equals root, while copy dot left and copy dot right so while copy left and copy right will increase the height. And then once one of them breaks, so we'll say the same height equals to false. And so can we say if copy, no, if while copy So let's think here, let's say, can we write another function, right, for get height of left and get height of right? Or can I say like while or that? So can we say like while copy dot left or copy dot right so I want to know the longest path. This has a path of 3, this has a path of 2, so you can max have 1, 2, 3, 4, 5, 6 nodes in here, which is the longest path. You can have 7 nodes in here. 3, between 1 and 2 to the power of h nodes inclusive at the last level of h. So the height is 3. I can have at most 2 to the power of 3 nodes, right? 2 times 2 times 2, which is 8 nodes. 1, 2, 3, 4, 5, 6, 7. Inclusive at the last level of h. Two to the power of h. So this has a height of 1, 2, 3. Okay, let's back up here. So in our helper function here, right? So this is going to be to basically whatever, helper, it's fine. So if not root, we return 0. Else you have a value for root. So if root dot left and root dot right, we're going to return root dot helper on root dot right. So return 0. So if the root dot left and root dot right, helper root dot right plus, or sorry, helper root dot left plus helper on root dot right. So that would return 0 at the very end plus 0 at the very end. On both of them. But we're not incrementing anywhere. So you increment, if you have a root, so you increment equals to 1 here, right? So we increase the count by 1, meaning that we're on a root, on a value. We increase, okay, count a height. If we go here, if there's a root dot left and root dot left, we go, whatever, left is equal to this. Or I'll say left is equal to helper root dot left. Right is equal to helper root dot right, right? If left and right, we're going to the node has 2 children. So we're going to say return count plus equal to elif left if left and right, we return count plus equals to elif left and not right, I return count plus equal 1, else we return count equal, no, we don't need to, so if right, so if there's no but 2 children, you return 1, you return 2. If there's not 2 children, you return 1 by default, because you return 0 right up here at the start if the root isn't there, meaning that you can't go root left. Well, hold on. No, wait, I'm being stupid. So if not root, I return 0, saying that we have no children, or that I'm not going to count this node. Oh, I'm tired. Oh, been a long day. Hey, boys. Been a long day. Okay, so let's think about this. We're going to be on a node. Do we want to count the node or count its 2 children? We want to count the node itself. So we don't want to return a value of 0. This gets returned back to here. If not root, you return 0. Else you count the node you're on, because you're on a node. You have to count the move you made. Count equals to 1. So you count the current node you're on. So this root is not none. So we're not returning 0 here. We're counting the current node. We're getting a left and right. If the left and right so we just want to say helper left. Left equals this. Right equals this. Right? If left and right, we're going to call so you have to keep a count. So let's go like this. Let's say if not dot left and not root, going to return 1 back. So we'll return 1 back on these leaves. Right? We'll return 1 back on these leaves. Left is equal to root right. Return 1 on the root. Or on the leaf, we'll return 1. Then we go left and go right. If you have both of them, then you call helper left plus helper right. So if left and right, you call return. If left and not right, call helper return helper left plus return helper right. I don't think this is right either, right? So if not root dot left and not root dot right, you turn right. So we go here. Okay, go here. Call helper on both of them and sum those values. So 2 got returned back. Returns a base value of 1. 1 got sent back. That's the call plus 0. So then can we just go like this actually? Return this. So if not root dot left and not root dot right, you return 1. If not root dot left and root dot right, you return 1. So if either or, you return 1. So if root dot left or root dot right, you return 1. If not root dot left and not root dot right, return 0. So if you have a case where you don't have either a left or a right node, you return 0. In the case if you have a left or a right node, you return 1 because you have you count the node you're on. No, that's for 1 children. 2 children. Count the number of children. So if it doesn't have any children, you return 0. So you return if it has a root left or right value. Return helper left plus helper right. So those are give 0, 0 back. Oh, no, not this either. Ah, sucking here, man. Sucking. Okay, so let's write a function called, or let's write a thing called for left height. So copy equals to root while copy root dot left you get the height. So while copy root dot left, copy dot left. Okay, we'll go length left equals to 0. Length right equals to 1. If, and so while copy dot left oh my gosh, my brain is not working. Ah! So the thing is if I want to check if I want to traverse, I have to take a copy of the root. I can't. Or I just pass in root on a local scope, but leave it. Right, so maybe we'll write a function to get left. So we'll say def get max h, get max height, or height, I guess. Brain not braining. So we'll say height given a root node. So let's write a function called travel left, which given a root node. And a count, right? So we'll say if root count plus equal 1. Root equals to root dot left, right? Travel left. Now we'll do the same thing. Travel right, root, and count. So if root count plus equals to 1 and root equals to root dot right. While root actually. While root count plus one count goes up. So then let's not do this. Let's just put in a count inside the function itself. Right, while root turn count. Let's do something similar here. So while root count plus equals 1 root dot left. So then what we're going to do is say return, and we'll say def helper given a root. So here we want to say if the root is alone, right? If the root is alone, we want, if the root is by itself, has no children, so if root is none, so if not root, return 0. Okay. Now elif, so if we return 0 if there's no root. Now what if the case if we have one child or two children? So then we'll say left equals to root dot left, right equals to root dot right. We say if left and right, return helper left plus helper right. If left and not right, return helper left else we're going to return helper right. So then what we'll do is we'll call these functions, say return return travel root left, travel left root if travel left root equals travel right root, else return helper root. Dang it. So if we return 1 back on no root call, we get to the 2, if we get to the 4, we would return 1 for this node. Three, one, one. This is returning 1. Return 2 to the power of travel node root. Travel left if those are equal to one another, else that. So if not root, you return 0. Three. Anybody have any tips? You guys are leaving me high and dry here. What the heck? So if left and right. Either or. One plus helper. Helper right. One plus helper right. I'll put one too many. This is full. Two to the power of inclusive at the last level of H. For tree height, having max nodes of 2 power H. For a height equal to 3, we can only have max 7 nodes, not 8. Maximum number of nodes that it can even height, assuming its height is measured in global edges, is 2 to the power of H plus 1 minus 1. 2 to the power of H plus 1. Height. So I say this. If that's less 1, so this travels, this counts 8 nodes here though. So actually, I don't even think we need to do this. Because if it's none, it'll return 0, so you'll get 1 by default. $12, 2. Double the nodes there. So we just want to count the current node that we're on, rather, not double it up. So 1 plus helper ref. Plus helper right. There we go. Come on, show me the money. Come on. Yes. Mine's slow though. No. Ah. No. That's such a bummer. Oh my gosh. Oh. Did I grow? No, I just finally stood up. I was slouching in CS major posture. I had CS major posture there. All right, so we have this where we have traverse left and traverse right, and then helper. So maybe we can optimize this a little bit better rather than calling. So let's go here. Let's say left is equal to travel left on route, right? So then if we let's just say, rather than calling these functions over again, let's just call them once. So if right equals to left, else call helper on route. So that ran. Does that run a little bit faster now? No, still stuck at the 3 milliseconds. So even by just calling it once. Professor today had to make an announcement to tell CS major Indians to shower and use deodorant? No way. Tim, you're lying. That is such crap. Hey, Jolly Rhino. Sorry, this is the question here. Epic Turtle God, you can try a recursive tree traversal algorithm where your escape condition is if the node is none, you return nothing, else traverse left, then right. You return nothing. While incrementing the count as well. Just do BFS with the Q. I thought that was like a stereotype, like a a CS stereotype. I didn't know that was. I bet it applies to all CS majors, not just that demo. Tim calling out that professor being a little bit racy there. That's a little rough. (1930s) no air conditioning. Okay, so let's take this. Let's go to the almighty orb and let's say, okay, I finally solved LEET code 222. I do believe there is a faster approach, and I would like to come to it. Can you help guide me without code to better my current understanding. Here is my current version. You're very, very close to the optimal solution already. Great job solving it. Your code is using good insight. The left height and the right height are the same. Then the tree is a perfect binary tree, and you can directly return 2 to the power of the height minus 1. You even have a recursive fallback helper if it's not perfect, which is correct. What is the bottleneck? In your code, when the tree isn't perfect, you fall back on the standard recursive count, which is O of n. It visits every node. That's fine, but there's a better way. What's the optimal insight? Ask yourself, at each node, can you check whether the subtree rooted at this node is perfect? If so, you can compute its size without traversing it entirely. Oh, that's correct. So instead of fully recursing both subtrees, you can measure the left height and right height. If they're equal, compute node count in O of 1 for that subtree. If not, recursive only the incomplete side. Oh, okay. Okay, I get it. Okay, okay. Hold on. So, aha moment, light bulb. So if we already know the heights here, right? So we can call helper on the lesser of these two. So else call helper on left so we'll just say this. If right equals to left, return that. Else, right, greater equals to whichever one's greater. We'll say if left, right, return helper on left, else return helper on right. So we already know, based upon the traversal of left and right, which one is which one is going to be incomplete or not. So based upon that knowledge, is whichever one is less than is the one we need to call the helper function on. So if left is none here, none type an int, not supported. So if So if the left is greater than right, so the right is equal as a non-object in this case. So left is non-type. Oh. So if the right height is equal to left height, okay, so we return uh, left height plus no right height. I think that's it. Oh no. Okay, we need to add one for the initial root node, right? Because our current function is only. What's adding in the current node? Okay, so let's see here. Okay, here is what I have so far. You have to switch it, no? You don't? You want the lesser of the two? Oh, maybe so. So I have it the wrong way? Let me get this. So if the left is greater than, we want to call helper on root right and add left height to it. Else helper root left and add the helper right to it. Or the right height to it. Because the left height's greater, so we want to add the left height to the call on root right. Yes, thank you. Ah, short one still. So if the two heights are equal, if the two heights are equal, we return this. If the left height is greater than the right height, we add the left height to all of the nodes. Oh no, so we would add not the left height. This is 2 to the power of h minus 1 divided by 2. So we say max nodes is equal to this here. And we'll say return max nodes divided by 2. Still. Right, because don't we want to return the maximum nodes, which is half the amount of nodes? If you guys are here, part of the crew, leave a thumbs up for my struggle. My name is Michael. I'm 26 years old. I got a degree in human biology and a minor in chemistry. And I work as a formulation chemist for a biotech company, and I've been teaching myself how to code for about 10 months now. We've built quite a few projects in this 10 months, and we've done over 50 leak code problems. We've read a few books. We've done a couple courses. We've really ramped up our coding skills in these short time. And we're going to continue going as I stream every single day around 7 p.m. PST after my job. And I learn and teach myself how to code every single day. So, well, the thing is I'm flooring this by 2. And so I think I'm just missing that root node, because in this case I capture them all. But in this case, I call helper on root.write, so I pass on the root node, right, our original root. And then I am adding half of these floored down. So I think I need to add just 1 here. And now if I run that, it'll pass the case, but will it pass the submit? No. Okay, let's see. I am stuck here. Here's the key thing that's still blocking. You're still calling helper, which is O of 1 traversal. I have to get the count. Oh, hold on. So I don't even need to call helper here. Because I just need to say, okay, if I can have a maximum of, right, 1, 2, 3, 4 nodes within this half, I have a height of 2. If you pasted something in the chat, I don't see it. I don't think it allows for paste, unfortunately. Can you paste it in the Discord? Your answer there is going to be B, to initialize the attributes of an object. you define the actual object itself. Defining functions that can be called on the object, those are just methods. And then a class method is a decorator that you can use to indicate a method that applies to the whole overarching class itself. So if you wanted to override, like a data structure that's housed in the class itself, containing all the instances of the objects, then you can do that. I've used class methods for that before, where I had like a list where I appended on instantiation all of my objects into the list, and then I used a class method to get the length of that list, because the list wasn't captured within individual objects, it was captured within the overarching class definite above the initialization. Or there's other, maybe you're not accounting for the root, since each time you increment the depth each side, you're already one level down. Nice, dude. Hearts up. So, imagine the structure. The left height equals the right height. The entire tree is perfect. Node count is done. The left height is greater than the right height. This means the left subtree is perfect. The height equals the right height. The left subtree is perfect. Height equals to right height. So subtree has... So left subtree has 2 to the power of right height minus 1 nodes. And 1 for the root. Then recursion on the right subtree, which might be incomplete. So count plus count nodes root dot right. What? There's 3. So the right subtree is perfect. Right subtree is right height. Huh. Count nodes. So it wants me to call this function on itself, which traverses left and right. Root dot left. Count nodes of root dot left. The right subtree has 2 to the power of right height minus 1 nodes. So I don't want to call a helper function. There's some logic, so return the right subtree is perfect. What is this? Travel left. Oh. Travel left. Ah. Oh, it's base 2. Let's self-thought. What? I don't get this. How did this have like a 70% completion rate? I am not following. Given a complete binary tree, all levels are filled except possibly the last. The last level is filled from left to right. You want to count the number of nodes. You're already using it. The binary tree is perfect, completely full, and its height is h, and the number of nodes is 2 to the power of h minus 1. You're correct checking that if the left height where your code's getting stuck here. The helper does a full recursive, which is O of n. At each node, check whether the left or right subtree is perfect. If it is, compute its size immediately without going into it. Only recurse on the imperfect side. So if we got to pass a count down. Say if root dot left and root dot right count plus equals by 2. So we compute a left and a right. If left and right count plus equals by 2, right? Else, if there's not, you call this so this is all I have for my helper function. You want helper root to return the number of nodes in the subtree rooted at root, using height comparisons to shortcut to full traverses whenever possible, whenever you can. What to do inside your helper: at each root, do these 4 steps. If the base case, if the root is none, right? So if root is none, so if not root, turn 0. Calculate the height of the leftmost path, root.left, and rightmost path, root.right. So is travel left, root.left, and travel right on root.right. We travel here on the helper. So this returns a count. If the height is equal to the right height, the tree is perfect. Return that. So if left is equal to right, then you're going to return the max nodes here. Okay. You return the max nodes. Else, if the left is taller, the subtree is perfect. And if left is greater than right, then we're going to return two to the power of right This is 122. Hey, Skewy Chase. Yeah, we've done about, I think this is going to be our 55th problem. This is our project that we're working on. I'll show you guys a quick preview of our project before I keep going here. It's currently using Fast API, and I have it linked up using Uvicorn to run a server on it, but this is what it looks like right now for actually generating plots for the chromatography, because I'm a chemist and I wanted to make a chemistry related project this go around. So I created this this chromatography visualization simulator. So you have a solvent that travels up, and then you have random compounds that were generated with random retention factors based upon this solvent, and you can see that they travel up at various speeds based upon that retention factor. So if you guys are familiar with chromatography, right, depending on whatever, the solvent has various properties, which we're not worrying about right now, but in this case, if the like dissolves like, so this compound has a very similar property to the solvent as it's traveling up in almost one-to-one unison with this solvent. Whereas these other ones, they have fairly, they have some relations, whereas these ones are really unrelated in terms of polarity or whatnot. Hey, John. I'll do you one here. I'll do you one better here. Not one better, but this is our small business manager community version. I built this project and then made a community version for my stream viewers to contribute to and do pull requests for contributing onto the project themselves. And so I'll do you one here. Bada bing, bada boom. I built all this. So this is the small business manager project. This is the project before the chromatography one that we built, where I built an entire Tkinter graphic user interface in Python, where you can take in inventory items, you can take in expenses, you can then transact those inventory items with sales or return types, and then those populate income statements for those various transactions, and then balance sheets for the remaining inventories left over. So, yeah. Man, we cannot solve this dang problem. So we want to return. So in the plain text it says, return this. If the left subtree is perfect, return 2 to the power of root dot right plus just helper root dot right. Oh, so we're going to return two to the power of left plus helper So root dot left. So let's see what that does. Okay, so if that's all we were missing is, then we don't need any of that other stuff. The recursion handles it. So then if we call turn helper root, hey Odin, how's it going? I've done this completely independent here. Okay, so left height, travel left, right height, travel right. If left height is equal to right height, we call -1. Return 2 to the power of right height plus root helper root dot right. If the left is greater, power of right height. Would it be 2 to the power of right? If the left is larger, we want to compute 2 to the power of left, no? And then 2 to the power of right here. We want to traverse the smaller one. So we got output expected of 1 here, we got output of 0. We outputted a 0 here. We called helper on root. There is a root. It didn't return 0. It traveled left, which there is none. It traveled right, which there is none. So it did 2 to the power of... So do we need a base case to say if left and right? If left equals to... Or can we say it here, like... Right, to return 1. If they're both equal and they both equal 0, then return 1, else return that one. Ugh. Calling helper root. I am stuck again. LOL. Leftmost and rightmost heights. You're handling the perfect subtree logic correctly, and your cursor calls almost exactly what they need to be. Incorrect node count in the perfect base. say -1. To account for the root subtree. So if it's equal to 0, 0, 2 to the power so if we have no subtree, right, and we just have a root node, left is none and right is none, they equal, so we return 2 to the power of none minus 1. You can't take 2 to the power of none. Well, this returns a 0. Oh, this returns a 1. Oh, I'm stupid. So we travel left. We travel left. Get back a 1. Over 0, 0. If left is equal to this, plus 2. Right. If left is greater than right, it wants us to do to the power of right. Helper root left with a +1 here. Power of left, helper root right with a +1. Return helper root. So the thing is that it's not going to pass this. What's it telling me here? What is it telling me here? I think you're wrong. This will return -1 for a single root and as in the tree. Two to the power of left +1. Left +1? This one? So then how, I'm not getting the right answer for these other ones though. 6, 5. +1. +1. I don't know, dude. This one is annoying. Left equals travel left, root dot left. I want to travel left on the root, travel right on the root. Eight. Total. Travel left, count equals 0. While node, count plus equals 1. Root, root dot. Helper node. If root, if not node, return 0. Left equals travel left, root dot, node dot left. If left is equal to right, 2 to the power of left plus 1 minus 1. If left we can just return we can just return 1 plus helper node left, helper node right. Return helper dot root. So if not root, we return 0. We get a left and a right of this guy. So we get the 1, the height of there and there. So can I call just root get rid of the plus 1 and then get rid of the plus 1 there. Can I travel left and right from root rather than root dot left and right, then return travel from root the node, you return the left 1 plus helper, so you still return 1 plus helper node left and right. Here, you do 2 to the power of the left minus 1, you return 0. Oh, sorry. Yeah, I can move the chat, my bad. Which was focused. So then if you run that, that will pass. So then, okay, so you can go, you call a left travel and a right travel. And then if you become on a node that's not a node anymore, then you return 0. Else you travel left and travel right. If the two lengths are equal to one another, you return this function here of 2 to the power of the height less 1. Else you return, you call helper root left, helper root right, and add 1 for the node, for the root node. Because the helper is going to get the height and check for perfect subtrees, right? And so basically we'll be getting the extended height of each. So like we're getting the height of each subtree essentially. So we are getting the height of each subtree, both left and right side. You're getting the height of the leftmost and rightmost path starting from the current root of the subtree. Yeah. Man, this one was a little bit tricky. All right, Duke of Cool 199. How's the learning coming along, my dude? Hey, dude, how's it going? Thank you guys so much for following along and joining me here. If you guys are a part of the late night crew, leave a thumbs up. We've been streaming for 2 hours and 51 minutes so far. We completed today. We did a LeetCode problem that took us quite a while to complete, and we started off the stream with watching the first episode of Corey Schaefer's Introduction to Python Pandas tutorial, part 1. So Corey Schaefer's a really great YouTube kind of a programming teacher, and so I really enjoy his videos. And so for the next couple of days, we're gonna watch at the beginning we're gonna watch a video a stream here. So I think there's 5 of them. So over the next 5 or so days, we'll get through this series and hopefully have some more familiarity with pandas and with Jupyter notebooks. So if you guys want to check out that was at the beginning of the stream. So we watched this first episode, and tomorrow we'll watch part 2 of the Pandas Python tutorial from Corey Schaefer. All right, you guys. Thank you guys so much for being here and joining me this evening. If you guys would like to subscribe and follow along, I stream every single day around 7 p.m. PST after my 9-to-5 job as a formulation chemist. I make biological controls that are used in patient diagnostics and research and development, and for kind of advanced analytical testing of precise biological analytes, like really precise microgram levels of sodiums or whatnot. So anyways, I really appreciate you guys joining me and hanging out with me here. I'll be back tomorrow. We'll continue on with our project and with our studies. So tomorrow we're probably going to go more project heavy, as I wanted to shake it up and because we did a lot of the project yesterday. So I think we might try to refactor the code of our current project even further. Now, yesterday we did refactor our code down to optimize it more and to have more fluidity with what an actual thin layer chromatography would look like in the lab. But we still have some more improvements to make, in my opinion, as we currently don't actually offer the ability to see the compounds separate based upon multiple compounds within a single element or set or whatnot. So in the chromatography, as we see those elements travel upwards across the plane, if they have compounds that are associated with them that will fall out earlier than later ones, then they will do so. So we can think about how we want to do that. We can also think about if we want to do it by color, right? So Usually you do use ink in the lab to have the separation of these colors based on their their affinity for the solvent or whatnot, and the medium of the actual chromatography for the solid phase. And so when you do this, the colors will actually separate away from each other. So like if you have like a like purple or whatnot, blue and red will separate out of it, and so um, we might be able to show that as well. So anyways, I'll see you guys tomorrow. Thanks so much for joining me here. Please follow me on GitHub. Join the Discord link down below to get access to all my resources completely for free. We're almost at 2,000 subscribers. Thank you guys so much for supporting me day in and day out. I'll see you guys tomorrow. Bye, guys. Have a good night.